What's going on, guys? In this video we are going to see how to find the operating modes of BJT. Here the question is asking, find the region of operation for BJT in the given circuit. Here we have two circuits. Let's call this one A and let's call this one B. Now there are two methods we can use. The first method is assume that transistor is in active mode and find the current IC, IE and IB and VC, VE, VB. So here we assume VB is equal to 0.7. If it's in active mode, it's 0.7, and VC should be greater than VB in order to be in active mode. Otherwise, it's saturation. That's the first method. The second method is assume that transistor is in saturation mode. Find IC, IE, IB, and VC, VE, VB, and then we see what is the beta. If it's greater than beta minimum, or we can say beta first, that is equal to IC saturation over IB saturation. And if beta minimum is not smaller than beta, it's not it's in active mode, right? If it's smaller than beta, it's in saturation. Our assumption is correct. But if this is not satisfied, then transistor is in active mode. So these are the two methods. Now here we are going to use the first method for these two circuits and see how to find out the which mode this is in. Okay. Now here we use the basic circuit analysis technique, like we use the KVL to find out the current first. You can see this one connected to the ground, so we know that whenever you have arrow, that's the emitter. This is emitter, this is B, and this is collector. B is base and this is collector. Here also arrow is here, so this is emitter and this is base and this one is collector. Okay. Now here we can say that emitter voltage is going to be 0 because this is connected to the ground. So VE is equal to 0. And also in order to be in active mode, this one, the voltage across here has to be 0.7. Okay. So voltage across the base and the emitter, VB has to be 0.7. Okay, this one should be VBE actually. This one should be BBE. Base VBE should be 0.7. It means VB minus VE. So we already know VE is equal to 0. So VB must be 0.7. 0.7, right? And also we have to find out the current, because now we have to compare what is VC and VB. If VC is greater than VB, then we say this is in active mode. Otherwise, it's going to be saturation. Now we know that VC is voltage across here. Okay. In order to calculate this one, we have to find out what is the IC current is. To find the IC current, first we have to find out IB, because the relation is here we have the beta, and IC can be calculated using beta IB. If we multiply IB by beta, that's going to give us the IC current. So after that, we can find the VC. This is a VC voltage. We can find the voltage current using this formula. First 10 minus IC, or generally we can write it as this one called VCC minus IC times RC. So this is the general formula. Now first we have to find out what is IC is, then we can, resistor is already there, that's 2 kilo ohm. Then we can calculate VC. Then we can compare VC and BB. After that we will know whether this is in active mode or passive, saturation mode. Okay. Now let's apply KVL here. Since current is flowing in this way, this is going to be negative 2 voltage. And then here we have 1 kilo ohm. So plus 1K times, this is current is, let's call this one IB. 1K times IB plus 0.7 should give us 0. Okay. Now this is negative 2. Let's go ahead and calculate. This is negative 1.3. If we move this to other side, positive 1.3. So IB is equal to 1.3 divided by 1K, and that's going to give us 1.3 milliampere. This is our IB current. Now beta is given as 100, so 100 times 1.3 milliampere That's going to give us 130 milliampere. This is our IC current. Now after we find out IC current, everything is easy because VCC is known as 10 voltage minus IC is 130 milli multiplied by 2K. So 130 times 2K, that's going to give us K and milli cancels. So this is going to be 260. So 10 minus 260, negative 250. VC is negative 250 and VB is 0.7 here. VB is 0.7. Here you can see VB is greater than VC. But in order to be in active mode, VC should be greater than VB, right? Since this is like contradicting this one, therefore this is in saturation. So this circuit is in saturation. So we have to do the same thing here. First we have to find out this current. So first we found out first circuit is in saturation. Now let's look at the second circuit. The equation again, we know that V is 0 because this is connected to the ground, and we know that in order to be in active mode, VBE should be 0.7. Since VBE mean what? VB minus VE. VE is 0, then VB must be 0.7. VBE mean the voltage across here should be 0.7. Since VE is 0, VB must be 0.7. Then we can find out the current using Kirchhoff's voltage law again. Let's use KVL. Minus 2 plus, here we have 10K. Previously we had 1K. Here we have 10K. 10K times IB, and then IB, then 0.7 plus 0.7 should give us 0. 2 minus 2 plus 0.7 minus 1.3. Minus 1.3 divided by 10, that's 0.13, right? IB is equal to 0.13 milliampere. This is IB, but we know that to calculate IC we had to use this formula. IC is equal to beta times IB. IC is equal to beta times IB. Beta is 100 times 0.13 milliampere. That's going to give us 13 milliampere. So this is our IC. Now we have to find out VC. VC is equal to VCC minus IC times RC. VCC is 10 minus IC is 13 milliampere, and then RC is 2K. Milli and K cancels each other, so this is going to be 26. 10 minus 26, that's going to give us minus 16 voltage. And since we have negative voltage, VC is negative voltage and VB is 0.7. Here VB is greater than VC, so this is contradicting. Here we have VC has to be greater than VB, but here VC is not greater than VB. Therefore this is not in active mode. This is also saturation. And that's how we determine the operating mode of a BJT. I hope this helps. Thanks for watching.